All right, everybody, welcome to Lab 3, which is going to introduce you guys to correlation and regression within Stata. So looking at Lab 3, the first thing that we're asked to do is obtain a bivariate correlation matrix, which includes the following variables, right? So the number of deficiencies, which is our primary measure of nursing home quality, then the percentage of Medicaid residents, which is our key measure of access of care. We also are using curl def, which represents the total number of life safety code violations, restot, which is the number of residents and certified beds, occupancy, which is the occupancy rate, or the percentage of beds that are occupied by a resident, aid HRD, which is the nurse aid hours per resident day, VOC HRD, which stands for the vocational nurse hours per resident day, RN HRD, which is RN hours per resident day, total hours per resident day, and then the total number of beds, which is a measure of organizational size. Right, so if you run the pw core command, you get a correlation matrix of all of the variables over here. Now, what we want to be paying particularly attention to are rows 1 and 2 here, because this is deficiencies and the percentage of Medicaid patients. And if we do this, we can just look directly down to see how strong the correlations are between these variables. Right, so for the number of deficiencies, we can see a strong positive correlation with the number of life safety code violations. We see a modestly strong relationship between bed size. So the more beds you have, the more deficiencies you're likely to have. Right now, if we look at the percentage of Medicaid, we can see that the restot variable, so the number of residents, is strongly correlated. Same thing with the occupancy rate. So if you have a higher occupancy rate, chances are you'll have a higher percentage of Medicaid patients. Right, and then throughout here we can look at some of the other correlations, but the primary ones are the correlations that these variables have with the number of deficiencies and the percentage of Medicaid patients. Okay, and so now that we've gotten a good summary statistic of the correlations here, let's move on to some regressions. And what you may have noticed for the regressions in this lab, it's asking us to include a single variable for our sector. And if you recall, right, our original variable for ownership has like 16 categories or something, right? But what we want to do is collapse this into 3 different categories. So we have a variable that's called private sector, one that's called nonprofit sector, and one that's called government. And so we'll do this by first generating a new variable, which is just a copy of our original ownership variable. So if we highlight that, we have a new variable, and we want to recode this new variable, own3, so that values of 1 through 3 is equal to 1, values of 4 through 6 are equal to 2, and then values 7 through 12 are equal to 3. Right, and so what this will do is give us basically 3 sectors. So next we're going to highlight we're going to highlight this line, which is going to tab our new variable and generate 3 new variables for each of those categories. Right, so we'll run that command. So this comma gen with sector, what this does is creates new variables. So this will be sector underscore 1, sector underscore 2, and sector underscore 3. Now what we want to do is rename those variables to private, nonprofit, and gov, respectively. So we'll highlight that, rename those sector variables. All right, and now we have 3 different sector variables that we can throw into our model. So let's see what it's asking for. The first thing is that it wants us to run some simple regressions with a dependent variable measuring quality. So we'll use the number of deficiencies. And our first regression uses restot, or the number of residents in a bed, as an independent variable. So we'll go ahead and run this command real quick. All right, and we get this stata output. And there are a couple important things that we should note, right? So it reports the number of observations here, 1,487 cases. We see the R squared, which is a measure for how much of the variation in your dependent variable you're explaining with your independent variable. Right, so one way to interpret this is that the number of residents in a nursing home explains about 1.8% of the variation in deficiencies. Right, so not a whole lot of information. And if we look down here, we see that there's a positive coefficient on this variable. Right, so we would interpret this as a 1 unit increase in residents predicts a 0.01 percentage point increase in the number of deficiencies. This down here, this 6.86, is the constant. And another way of interpreting the constant is if the number of residents was equal to 0, our baseline value would be 6.8 deficiencies, right? So that's the intercept. Now what we can do is run a scatter plot between these two variables, right? And this is the relationship that we see. Now, what I'll do is add a linear line to this, and that'll show you the slope. All right. So this line, the slope of this line is 0.016, just like the regression output, right? So we see a slight modest increase here. Now also keep in mind what happens when the value of x is equal to 0, right? We see that baseline value of about 6 that we saw as the constant, right? So every 1 unit increase in this x-axis increases the slope by, what is it? 0.013, right? So we start off at 6.8, that's the intercept, and every increase of this variable predicts a 0.01 percentage point increase in the number of deficiencies. Right, and so then here I have another example. We'll skip that one. But what we'll do now is I'm going to represent government nursing homes. So let's run a regression here real quick. All right, and the interpretation of this variable changes a little bit. So instead of saying a 1 unit increase in a government nursing home, the interpretation would be relative to the private and nonprofit nursing homes. Government nursing homes have 1.6 fewer deficiencies on average. And our constant value in this case represents the average number of deficiencies for private and nonprofit nursing homes. And once again, right, so we see the number of observations up here. We see an R squared, so we don't really explain much of the variation in the deficiencies at all. Now, finally, what we'll do is I'll run one of the access models, right? So now we have a different dependent variable, which is the percentage of Medicaid patients, and we'll use the number of residents in certified beds as our key independent variable. So we'll highlight this command and run it. All right, and so what we see here is that a 1 unit increase in the number of residents predicts a 0.11 percentage point increase in the percentage of Medicaid patients. And once again, if we went to the point where this variable is equal to 0, we'll see that the baseline is 52% of Medicaid patients. All right, and I have just down here to make a graph for ourselves, but let's just type this out real quick. So we'll do graph two-way scatter P Medicaid res dot, and then we'll put a linear fit on here. So we'll shoot a straight line through it. All right, we run this command. Right, we see here at the value of 0, see the y-axis is equal to about 51, right? So the baseline is that the nursing home has 52% of Medicaid patients. But for every 1 unit increase in the number of residents in a bed, we see that slope increase. And that slope here is the exact same slope that we see here. Right, so we see a positive association.